Let's talk about causality. So, something I see from a lot of theists, I was guilty of it when I was a theist, is this assumption that causality or the law of causality, and I put law in air quotes because, like all of the laws of physics, and I'll touch on this much more in a separate video. Like all laws, the law of causality isn't a law in the sense that it literally applies everywhere all the time. I'm going to touch on that more in another video. Like I said, I want to focus specifically on causality in this video. And the thing about causality is it doesn't apply to everything equally at all times, universally, in reality. It just doesn't. Causality, for the most part, at least as we understand it, completely breaks down at the quantum level of reality, and even a little bit before that. Well, I suppose because atoms, for the most part, are defined quantum mechanically, that would still be at the quantum level of reality. But there's a level of stochasticity to aspects of chemistry, even, that involves molecules. And to an extent, certain molecules can be defined quantum mechanically. But the idea that causality is this thing that's always true 100% everywhere at all times is not true. One of the easiest examples to go to is weak radioactive decay, or just radioactive decay. It's essentially causeless. That's what the word stochastic means. And a lot of people will say, well, no, Leo, doesn't the instability in the nucleus of the atom cause that nucleus to decay? No, actually. The instability of the nucleus is the environment under which, or the condition under which decay can happen. But it doesn't determine that nucleus to decay at any given moment. That is literally indeterminate. This is why when we measure with radiometric dating, we have to use half-lives because you cannot determine when any one atom will undergo decay. It is stochastic. There is no antecedent determinant factor that makes that one nucleus decay at that time. Those factors just don't exist. So it is essentially causeless. Another good example would be tunneling, like proton tunneling that occurs in the cores of stars, whereby when the wave function defining a particle hits a barrier, generally the wave function will be deflected, but every so often it will hit and then some of it will tunnel through that barrier. And so, like I said, in the cores of stars, what happens is protons, when they get really close together, given that they both have a positive charge, there's a repellent force there. That's called the Coulomb force. But every so often, protons can tunnel through that force where they're within the range of strong interactions, which will pull the protons together. That's also how two positively charged particles, two protons, can be held together in the nucleus of an atom, because that is a question that I get. That's because they're so close that strong interactions take over, and strong interactions are stronger than electromagnetism. So we know of numerous instances where causality, at least as we understand it, breaks down. Most would say that causality just breaks down. It's not that there's still some causes here that we just don't know about. It's that there are actually no causes for this. It occurs because there's a probability that it can. Another really good example are vacuum field fluctuations, or the quantum fluctuations. That was a term that I was thinking of. Most people probably know them as quantum fluctuations, which is really kind of hard to explain, and I will probably explain those in one of my Dr. Eigenstate Explains videos at some point, because it isn't what when a lot of people hear about quantum fluctuations, it's often simplified to make it easier to understand, and it's not that that's necessarily inaccurate. It's more that it doesn't really capture what's happening. But these events are also stochastic. Nothing causes a quantum field to fluctuate. It's just an inherent property of it. There are no factors of the field prior to the field, or prior to a fluctuation in that field, that make that fluctuation happen in that field at that point at that time. It just does. There's a probability that it can happen, so it does. And for the people that have a strong understanding of statistical probability are probably going to understand what stochasticity is, and how causality isn't something rather that it's something that can and does break down at a certain level. in reality. But that's something that I thought that I should make a video on it because it's getting annoying hearing, well, you know, what caused matter and energy to start existing? What caused space-time to start existing? You're assuming that there was a cause to begin with. And just because at the classical level of reality that we exist at and interact with in our everyday lives, that we experience things having causes, like if, you know, something falls over, somebody hit something, or the wind blew, or what have you, there was some antecedent determinant factor that made this thing fall over. Whereas there are places and times and levels of reality where those antecedent factors are just not there, yet the events still happen. And I know that it can be hard for one, especially one who might not be as well versed in, like, say, statistical probability or in quantum mechanics or anything like that, to wrap their head around how events can happen without causes, but they can. They most certainly can. And a lot of people try to, like, especially in the examples that I give, because the three that I gave are the ones I most often give, they try to find little things that they can call the cause, and there isn't one. At best, you could say there's a material cause or a material from which this new effect is arising. But when people talk about causes for things happening, they're generally referring to the efficient cause, the thing that actually acts on the material to produce the effect. So you could say that the material cause of a piece of paper that's sitting on a table outside blowing off the table was the wind. The wind is the efficient cause. The wind is the thing that acts on the paper to blow it off the table. So I would say that, yeah, it's accurate to state that there are material causes for these things: the nucleus of the atom in weak radioactive decay, the proton or the other particle in quantum tunneling, and the vacuum field in reference to quantum fluctuations. But that isn't generally what most people are insinuating when they talk about causes. So hopefully this short video has helped people understand why appealing to causality as a law that's universal and applies everywhere really doesn't work. In our everyday lives, yes, it's reasonable to assume that if an event happens, there was some at least efficient cause, and thereby assuming some material cause, because if there's no material cause but there is an efficient cause, there isn't anything that can be acted on to be changed, so you would just not have causation wouldn't be happening. But I can go more into that in another video. I don't know when I'll do that though, but that is something that I want. Actually, that would probably relate to a video I might do as it relates to first cause arguments, just because. Anyway, getting off track here. Hopefully this short video has helped people understand why assuming that causes are universal really isn't the case. And as always, if you like the content that I am producing, please subscribe. Consider ringing the bell so that you can be notified of any new content that is to come, because there is a lot of content that is coming. I originally planned on making this video Monday, and I was busy Monday, so I was going to do it Tuesday, and it was busy Tuesday, I was going to do it yesterday, and then it was busy yesterday, so I figured, well, I'll do it today while I have the time and get that done. I also plan on doing another live stream probably sometime early next week if I'm not busy, and I shouldn't be. I will be doing my response to Hunter Braxton's 10 Questions for Atheists. I watched like 2 months ago or something like that, like the first 10 minutes of it, but I didn't watch the full video. I don't want to watch it before doing the live stream. I want my answers to be raw and uncut right then and there, because I think that's more genuine. Also, if you are a fan of the interwebs and you have a Twitter, consider following me on Twitter at Leophilia, spelled the same way as it is with my channel. And, as always, per causam nos perfectum, or through reason we progress.